Hello and welcome to this short tutorial on how to use RMarkdown for lecture notes in computer sciences. In order to install the required packages, the first thing you need to do is go to github.com/statistics for social science, and when you follow this link you will come to this overview of a set of packages that I've developed in order to help you with this process. And the first one is called RMD templates, and this is the one that you're going to need. By clicking on this link, you will come to the repository of the RMD templates package. And in order to make this as simple as possible, scroll all the way down to install instructions, and everything that's here on top of this gray background, you basically copy. And when you switch to RStudio, you can enter this into the console. And if you don't have the required packages such as DevTools installed, it will install them for you automatically. After running this, you will see that the package will install. In my case, it does not, because I already installed the latest version a couple of seconds ago. And it could ask you whether you want to update other packages that are currently on your system. And I would, you don't have to, but in my case, I just updated all the other packages as well. When you have the Markdown templates installed, you restart R, which will basically also restart RStudio. You can also do this by pressing Command-Shift F10 on Mac computers or Control-Shift F10 on Windows computers. And when you're in a project, like I have now opened a demo project, you can now create your document file by going to File, New File, RMarkdown, and going to the From Template overview. And in this list, the list will be probably differently ordered than mine. You will now find Springer LNCS, Lecture Notes in Computer Science, and you can give your article a name. I will call this my article, and this will be the folder name where your new document will reside. When going inside of this folder, you will see that there are a couple of files that you can use in order to write a Lecture Notes in Computer Science article. First, you have this anonymous authors.txt file, which is basically the same as in the original Springer template. And then you have authors.txt, which I think I updated just a little bit, but this is where you would type in your author information, like the running author, the full author names, the institutes, the email addresses, web URLs, and so on. And the benefit of having these two as text files is that you can easily switch between the anonymized version for submission and the non-anonymized version for the camera-ready version of the document. You still need to supply the title to your article. So here you would write my article or whatever your title would be. Then you have the author input file. In the case that you want to create the anonymized file, you have anon authors.txt, and if you want to submit the non-anonymized version, you can basically switch this to authors.txt. The abstract goes in here. It's important to keep the tab in the beginning that Knitter will recognize this. Here you will have keywords that are printed on the document, and the separator between keywords is 2 backslashes and an and. It automatically includes 2 bib files for references, and these settings will basically set you up with a document that is conforming to the Lecture Notes in Computer Science. The other files that we have is this bibliography.bib. This is where you would put your own references. And we have another package which is installed required packages. This has a set of packages that you could install that will make things easier, but you don't have to. I think the dependent ones are installed automatically. Then we have the LNCS class file, we have the template file, we have the bibliography style file, and these are files that are you will submit them with your submission typically, but you do not change these files unless you you find it necessary to change the template, which of course you can freely do. This is the actual article that you're writing, and then there is a file preparebibliography.r, which is used to generate the R packages bib file that I just talked about here in the original article, we have this rpackages.bib, and this thing is automatically prepared when you call this when this R file is sourced. Currently, what this does, it has a vector that contains the list of packages that you want to cite. In this case, it would be knitr, tidyverse, RMD formats, cable extra, scales, psych, and RMD templates. And when this is called, it creates a chapter in your document that will contain the information of the packages that you're citing. So the main article now has a setup chunk, which is not included in the document, of course, but it sets up knitr in order to prepare a document as the lecture notes in computer science want this. So it includes the RMD formats library, the tidyverse library, and the couplet library. If you don't need these, of course, you can remove them if you're working with Bezier. But the sample that I've created includes these two libraries. Now you basically can write chapters with one hash symbol, subsections with two hash symbols, and second level subheadings as with 3 hashes, or this is actually the third level, and you can enter paragraphs using 4 hashes. Interestingly, knitr creates a label for referencing for these sections automatically. So for example, if you want to create a reference to this subsection, a subsection sample, you can easily refer to this by using something that is amusingly called kebab casing. So you just write everything in small letters and connect the words using dashes as a reference. In order to ensure that these references are not separated from the identifying word, for example, here a table is referred to, and you don't want to have a line break in this place, you would add so-called non-breaking spaces in front of the ref or the citation, which you can easily create using option and space on Macintosh computers. And I think there's another combination for Windows computers which you can easily look up. Otherwise, you can basically copy this symbol if you want to. Citation works typically, as in all Markdown documents, by using the where is it? In the bibliography, we have 2 BibTeX entries, some of my work here, and you can basically copy the citation key, and by using @citation key you can create a reference to this article. If you put it in square brackets, it will be entered as square brackets in the document as well. And if you're using it without the square brackets, you're citing the name plus the square brackets, which sometimes can be useful if you want to say who is actually doing the work. The environments that are available in the Lecture Notes in Computer Science template are available as well. These are the examples for how to provide a theorem or how to enter equations. You can just copy the LaTeX command here as well. And this is one of the important things. You can normally use LaTeX commands in a RMarkdown document as well. If you want to create tables, I would suggest that one table is the output of one Markdown chunk. Of course, you do not want it to echo the code, just the output. And in this example, I use the iris data frame, take only the top 6 entries, and put this into the cable function from knitr. And here is where I can also give the table a caption. In this case, the caption is just test, and I can insert a caption label as well by adding it in here and escaping the backslash of the label function, and then I can refer to it here using the ref function. You can of course also add tables directly as LaTeX. So this is the table from the original template. This will also be in the document. And if you want to refer to figures, figures are always created with a label that has the prefix FIG and colon, and then the part after the colon is the name of the chunk where the figure is generated. So in this case, down here you see this is the chunk 3 is called fig1. That's why here I can refer to fig1. I can give the plot a caption as well by the additional parameter fig.cap, and this will be entered below the picture. And in this example, I'm basically using a histogram on the iris dataset and using the cowplot minimal age grid as a theme. And figures are always spanning 100% of the text width configured here using the out width. If you want to have smaller figures, you can always change them in the individual RMarkdown block. You could go out width to 75%, and then the figure would be smaller. Of course, you can also change the aspect ratio by going figure aspect ratio and putting it to 0.04 or anything that you see fit in this case. The last thing to mention is that we have down here a chunk that is not evaluated and not included in the output currently. And so if you're happy with the normal result, I can knit this document quickly to show you the outcome of this. Now this creates a set of files, and this is the result of this RMarkdown rendering process is a regular lecture notes in computer science file with those two references. The figure is scaled according to the aspect ratio, but to 100% output width. And yeah, the references work, so I can refer to the tables and I can refer to the citations. One thing important to note is that the citations you have to arrange yourself. What this will not do is sort them in according to, so typically in this case multiple citations are possible. As you see here, I'm just using two in the same square brackets with a semicolon in between, but the output here is ordered 2 then 1, and I would probably switch this around, have 1 first and then 2. So this is the only manual process that you have to do, but you can do this like in a last step. The other thing is that I talked about citing the R packages that you're using. If you want to give credit to the tidyverse and to cowplot in this example, what you could do is go to this prepare bibliography file, add the package names that you're using, and then by going to this last section where eval was set to false, if you set this to true, and if you set include to true as well, this will create, as it says here in the comment, a tight list of all packages added to the prepare bibliography. And you can, if you knit this document now, it will add a section, as stated here, that includes, where is it? A list of the packages used, which is basically a dash package, name of the package, author, and then the citation. And these are cited down here. You could, of course, reformat this by editing the prepare bibliography.r file. One of the reasons I included this and did not make this into a library function is so that you can adapt it to the way you want to cite it. If you, for example, want this to be in as a note where the packages are mentioned in square brackets, you can easily adapt this paste function. And if you don't want it to be as a section but as a subsection, for example, you could add 3 hashes here, and this will now move the used packages on the 3rd level of the table of contents. And now, where is it? It is now down here as used packages without numbering because it's on the 3rd level. Yeah, this is basically how you're creating lecture notes in computer science articles. You can use these files for submissions by, if you want to submit this article, it would include either the anonauthors.tech, the 2 bib files, the class file. You don't need this LNCS template because this is now included inside of the myarticle.tech. This other bib file as well, and of course you have the PDF file. The pictures or the figures created are in the myarticle_files folder, so you could use them in Ausselection as well. And if you then submit the camera ready, you will supply the authors.tech file. And I hope this is helpful to you in creating lecture notes in computer science articles. And if you have any ideas how to improve the package, feel free to comment them in issues in the GitHub repository. Thank you very much for your attention, and I hope you enjoy using this package.